The distributive property of multiplication. This is one of two different distributive properties, and they are essentially used to help you simplify your algebraic expression or algebraic equation. And in doing so, you're simplifying, in this example, with multiplication. So some problem that might require the distributive property of multiplication would be 2 times the quantity. That's what you say when you're saying like times the stuff inside the parentheses. 2 times the quantity of 4x plus 3. So here are some different ways that you could solve that. The first strategy is called the box method. Let's pretend that we have an example that is 4 times 2 plus 8. Now, we know that we could follow the order of operations and say, oh, inside my grouping symbols I have 2 plus 8 is 10, times 4 is 40. There's my answer. But when we're looking at a problem like 4 times 2x plus 8, then you can't add 2 x's and 8 1's, so we need a different strategy. Our first strategy up, is called the box method. Going back to just my numeric example first, if I draw myself a box right here, on one side I have 4. Here I have, well, that's not accurate. Here I have 2 plus 8. Now we know that the whole length of 2 plus 8 is 10. So I could find my area of this box by saying 4 times 10 is 40. However, if we didn't know that, or we couldn't figure that out, we could say, well, 4 times 2 is 8. 4 times 8 is 32. And if I add them together, well, 8 plus 32 is 40. So we can use these boxes to help us solve problems that have variables in them. Let's go back to my variable example, 4 times the quantity of 2x plus 8. I can solve this and distribute, which means give out, my times 4 to every term in my parentheses. Using the box method, I have 4 on one side because it's what I'm multiplying outside my parentheses. Inside my parentheses, I have 2 terms, so I'm going to split my box into 2 groups. I have 2x, and I have positive 8. Well, doing a little bit of multiplication, 4 times 2x is 8x. That's 4 groups of 2x's. If you added them all up, you'd get 8x's. And 4 groups of positive 8 would make positive 32. So this simplified expression would be 8x plus 32. Now, another strategy we can think about is going way back to the very first lesson of math in 6th grade and thinking about groups of. If I have 4 groups of 2x plus 8, then I'm going to have 1 group, 2 groups, 3 groups, 4 groups, and in each group I'm going to have 2 x's and 8 1's. The total number of x's, if I counted them all up, would be 1, 2, 3, 4, 5, 6, 7, 8 x's and 32 1's, and they are all positive. So there's another way I could solve that distributive property expression. Another really common way to model your distributive property, and one that you might see in tests or exams where you're given it this way in the picture form and asked to say what this expression is with algebra tiles. The setup normally looks like this. In the corner there's a little dot, and that means multiplication. On one side, I'm going to put whatever I have outside my parentheses. 3. 3 is not a variable, it's made up of 3 1's. So I'm going to put 1, 2, 3. Then inside my parentheses I have x plus 2. That's going to go on this side. X plus 1 plus 2. Now a dot like that means that we are multiplying. So I'm going to take 1 times x, that is 1x. 1 times x is 1x. 1 times x is 1x. 1 times 1 is 1. 1 times 1 is 1. And as you can see, the pattern continues. And I'm able to model with algebra tiles my distributive property, the multiplication that's happening in my distributive property. What's on the inside of this box, that's my answer. I can count up my x's. I have 3 x's, and I have 6 1's, and they are positive. So the answer to 3 groups of x plus 2 is 3 x's plus 6. Like I said, a very common type of problem is that you might see this picture and be asked, what does this represent? What multiplication problem does this represent? I know my answer is 4x plus 4, but what is the actual multiplication problem? To solve that, you look at each side. Here, I have how many? I have 2. Here, I have 2x plus 2. It would end up looking like this. This would be my algebraic expression because on one side of my parentheses, I have one side, and on the inside or the other side of my parentheses, I have the other side of my drawing. The arrow method is not like a specific method, but it's how once you are comfortable with the visual ways, the drawing out methods, maybe you might want to switch over to this arrow method just to save yourselves some time. Here's another example. So what I use with my arrow is I distribute, which means give out equally, my multiplication to each term inside my parentheses. So I say 3 times x is 3x. 3 times positive 3 is positive 9. 3 times negative y is negative 3y, and that is my distributed expression. Sometimes you might run into an expression where your single digit, the thing that you're multiplying outside of your parentheses, is on what you would think to be the opposite or wrong side. This still signifies multiplication. You can still work your problem out. 3 times 2, which is a positive 2, is 6x. 3 times positive 4 is positive 12. 3 times negative 3 is negative 9. And 3 times positive x is positive 3x. This might not be your last step. As you can see here, I have some straight up numbers, and I have some numeric coefficients with variables. I can continue to combine until I have simplified my expression as much as possible. 6x's and positive 3x's makes 9 total x's. Positive 12 and negative 9 makes positive 3. And this is my most simplified algebraic expression. Those are a few examples of how you use the distributive property of multiplication to help you continue simplifying your algebraic expressions.